Welcome everyone to this special webinar, part of the Cambridge Zero Festival. I'm Sylvie Russell, Head of Operations at Cambridge Cleantech, and we are here as a networking organization. We enable everyone to connect through events, but also through opportunities. So if you are an investor, an academics, a person from the public, an innovator, and so on, please come and see us, visit our website. We have a lot of opportunities for all of you. So today, what we are going to talk about is about climate positive solutions, focusing on sustainable smart homes and focusing today in Cambridge. So to do that, we're going to give you a few examples from solutions for a new home, if you're thinking of building a new house, to retrofitting, and then moving on to new developments. So first of all, I would like to welcome Beatrix Schlarb-Ridley, Director of Innovation and Impact at the British Antarctic Survey. But today she's going to speak about a personal point, which is the way she built her house. Beatrix, over to you.
Thank you very much indeed, Sylvie, and hello everybody. It is a real pleasure to reflect on our family's PassivHaus project with this particular audience, because Cambridge Cleantech networking events have been quite instrumental in making it happen in the first place. When we went through this journey, we greatly benefited from input from others, and were particularly in the run-up to building the house. And wherever it's helpful, we are also keen now to share our experience with others. I would please ask you to note, though, that this is not an eco-purist project. It's a story of finding workable compromises. So let me start with some key features. In addition to the general PassivHaus principles, so our house is not connected to the gas mains, and from the start has had all renewable electricity providers, so it doesn't use any fossil fuel. It has no central heating, and compared to the place where we lived before, we've almost doubled in size but halved the energy consumption. We tried to lock carbon up in the building materials wherever we could. The house has a timber frame and walls. There was one steel bar necessary for structural reasons, and sadly the foundations did require quite a bit of concrete and steel. The wall cavities are insulated using warm cell, it's basically recycled newspaper, and for the roof we did have to use earth wool because of space constraints, and that's recycled glass, formaldehyde free. We were quite keen to minimize drinking water use, so installed an underground rainwater harvesting tank with sufficient capacity to flush the lavatories and water the garden. And only once so far, and that was during the prolonged drought in 2018, did the tank run empty and the mains water had to kick in for those functions. This summer, it was fine. So let me take you through the house build story, starting with the foundations. The concrete slab helps to provide thermal mass to the otherwise mainly timber frame building. We went for a partial offsite build of that timber frame. The first photo is at the site of Anson Timber in Suffolk, who prefabricated these cassette boxes. And on the right, they're on our site. Here, the ground floor walls are being assembled, leaving space for the south-facing windows for solar gain. And on the right, the partitions and ceiling are going up. Here you see the floor being installed upstairs on the left and the walls going up on the right. This is the upstairs now with the ceiling installed. On the left before, the OSB boards were fixed onto the walls and ceiling, and on the right afterwards. And they created that 40-centimeter cavity for the insulation. On the right, you see round holes in the OSB boards. That's where the warm cell insulation was blown into the cavity, and then the OSB discs were put back in, and all walls and ceilings were covered with airtight membrane, which you see here on the left, together with the triple glazed windows being installed. The membrane is secured with wooden batons, and on top of those go the plasterboards. And from then on, basically, it looks like any other new build. The extra 10-centimeter gap that's created by the batons between the membrane and the plasterboard, I'm not sure whether you can see my mouse following the batons here, is essential to avoid anyone by accident puncturing the airtight membrane when they put a nail or a screw into the wall later on. So here you see one of the key features of a passive house, the MVHR unit. On the right, a passive house schematic. Our house doesn't have a basement, so the MVHR sits in the ground floor rather than underground. And we also don't have this long blue loop of a subsoil heat exchanger, unfortunately, but take the air in directly from the north facing side of our utility room. Another key feature of the is the rainwater harvesting tank that feeds the toilets and the garden tap. On the right, you see the installation schematic, and on the left, the internal control unit with the mains water backup. Essential to controlling solar gain for the south-facing windows are the external Venetian blinds. In summer, we have them continuously down with the slats horizontal for shading, because if you forget to do that during sunny days, you literally roast. So let me finish with a list of benefits from the start of the project that the completed house was to offer. The energy efficiency is certainly excellent, and our energy bills have reduced substantially. The red cross next to the green cube isn't really related to the passive house performance as such. This was a next generation MVHR system that was under development to include water heating from surplus heat. And we were meant to be the first installation. Sadly, that fell through quite late in the project. And we ended up with a conventional MVHR and an electric water heater. In that stage, it was too late to switch to solar thermal heating. The high user comfort depends on how you define it. In the first winter, when we just depended on the systems as they were installed, the temperatures did go down to about 14 degrees at times, and we decided that wasn't thermal comfort, and we did need some additional point sources of heat. We bought 3 small electric radiators, which we use on timer functions and mostly at the lowest setting during the depths of winter when the days are very short and therefore solar gain is minimal. And that works very well. The advantage overheating through the MVHR centrally, which was the original intention, actually is that we only heat those spaces that we actually want warm. I don't want a warm bedroom, for example, or a warm guest room when there's nobody in there. So these point sources of heat actually work better for us as users. And after a period of trial and error, we found a setup that gives us the user comfort that we are after. And in summer, if we were to rely on the MVHR only to ventilate the house, it wouldn't cool down sufficiently overnight. But again, there's a very simple solution. The easiest is to open windows during the cool periods of the day, late in the evening or early in the morning, and let natural draft do the air exchange. And again, as long as it does cool down overnight, that works extremely well. It doesn't keep the pollen out, though, and one of the reasons that we wanted to build a passive house was because of allergies. Accessibility for servicing has been okay. The filters in the MVHR need changing every 6 months or so, but we can very easily do that ourselves. Minimal acoustic values, again, that depends. In positive terms, the triple glazing is an amazing insulator, not only for thermal, but also for sound. That the MVHR does produce background noise. So while we don't hear any noises from the roads outside, there is background noise internally, but mostly that the unit is on its lowest settings, and then the background noise is very minimal. The constant air exchange works a treat at getting rid of odors such as cooking smells, and it's also very helpful for humidity control in all the living areas. In the bathroom, we do open the windows straight after taking a shower to help with getting rid of moisture, and with that, moisture has not been a problem. So finally, to share the key lesson: to aim high, but accept that one will likely need to compromise in the process. As I mentioned at the start, we had much grander plans initially, but couldn't help that some things fell by the wayside in the process. maybe because of lack of availability or timescales or financial implications or opposing drivers, especially ease of maintenance. So aiming high initially meant that most of the key sustainability features were retained in the end. So this was very much a whistle-stop tour, but I hope it has contained some useful information, and I'll be very happy to expand on this during the panel session. Thank you.
Thank you very much, Beatrix. Really grateful that you are here today, and share your experience and your 8 years within that house. And I'm sure you will find more benefits and maybe smaller inconvenience over the next few years. So thank you very much for this. Now I would like to invite Salvatore from IntelliHeat. So we are not always able to, have a new house and build them ourselves a new system and, develop a house that is really fitting for one's purpose. But there are solutions to retrofit your own house and to make it more efficient. So Salvatore, over to you.
Thank you. Thanks, Beatrix. That was really nice. Thank you. Nice share. I'm very grateful as well to be here today. Thanks, Cleantech. My name is Salvatore. I'm the managing director of IntelliHeat manufacturer. We build, design electric radiators. Our venture started about 21 years ago. 21 years ago, we invested a lot of money into smart technology. So in real terms, what we did is control electric radiators, electric heating. It is today more a building management system, an heating management system. The average UK household emits 2.7 tons of CO2 every year. So in real terms, the big elephant today in the house is the heating. Those are basically the measure as a managing director of a company that we took. Okay, we can change the building of the fabric of the building, upgrade, double glazing, triple glazing, but the big chunk for us, it was the heating. The steps we took: enforcing Eco Design Law 20 legislation, try to change the new SAP 2012-2010 methodology of calculation, intelligent heating control, Internet of Things, accurate heating zoning, as you mentioned, Beatrice, is important to don't want more part of the house that you don't need. Heat or renewable, and life thinking, circular economy. Eco Design Law 20 is a basic one, 2018 legislation that basically offer clients the possibility to use intelligent heating control. The key principle of the Law 220 is that basically you cannot use an analog thermostat like a storage heater, panel leader, or the uncontrollable one. You need a temperature control that is accurate. You need an adaptive temperature control, an eco start, a smart open window detection, presence detection, real-time energy consumption, and self-programming. And of course, if you can, you do a Wi-Fi heating management control. We got all that in our product. The second was the SAP, trying to convince Brett that it was a little bit unfair to have only Dimplex storage heaters on the SAP, bearing in mind that there is loads of product available today and they're much more efficient than storage heater produced in 2006. Control is the key of our product, bearing in mind that since we integrated in 2001 smart IoT, Internet of Things technology feature inside our products, we reduce probably by 35–40% energy consumption in each house in UK. So that's about 60,000 houses so far. It's all about zoning. With our energy management system, with our heating management system, we can control individually each radiator, each zone. So let's say we can control 1,000 radiators based in Glasgow or Edinburgh or everywhere in UK at the same time. those are all the functions that we have built in our products. They're not gadgets, they're energy consumption reduction feature. So you can control in real time your heating. But most importantly, I think the app, the cloud-based app, will automatically adjust all the settings. So you put the program in, fine, leave it run for a week. The app will come back to you with a feed, and it will suggest the best option for your lifestyle. That means it's going to adjust automatically because they've got sensors. They're going to adjust automatically temperature, background, comfort temperature, but most importantly, the running of the system. So it's all about Internet of Things. Our future rely on, in fact, on interconnected system. Our cloud-based app will control the heating, but will control as well the hot water. That is another big chunk. Hot water, lighting, everything with electric, basically. Again, that's a screenshot. Why we want to control 0.1 degrees, because 1 degree in a room, 21 instead of 20, is £65 per year on your bill, and it's 330 kilos of CO2. Of course, all the radiators, they work on PV. And our latest baby, I call it baby, is creative radiators. So they're basically radiators that they have been designed with recycled marble. So all what you see there is all recycled. And of course, it's life cycle thinking and sustainable technology as is Summit, basically. Thanks for your time. If you got any more questions, I'm quite happy to answer any question you may have. Thanks for your time.
Thank you, Salvatore. Thank you for sharing, what you're doing in terms of making the radiator more efficient. And I think this is quite a subject, especially now and throughout this winter. So I don't think you're going to have time to go on the holidays. You might be quite busy in the next coming months. So thanks for that. But what about the house? We talk about the house today, but there is another point that is quite important. And we've seen in our with our members, also through different webinars, that the house and the vehicles are now can become as one. If you have an electric car, how are you going to charge it? There are solutions to charge it directly into your house. So we thought it was quite good also to introduce you with solutions for EV chargers, and also helping providers, energy providers, to see how to explore to the right EV charger that could go with the house. Tom Woodnott is a product manager at Right Charge and is going to join us now to share his solution. Tom?
Awesome, thanks very much. I'll just share my screen with you guys. There we go. Oh, apologies. I really need to change my background, don't I? Hi guys. Yeah, thanks for the introduction. Yeah, I'm Tom, a product manager at Right Charge. I was originally a mechanical engineer, focusing my dissertation on Formula 1 cars, which is pretty cool. But really got interested in clean tech when realizing the impact of traditional cars. So yeah, I joined Right Charge, and we are a marketplace helping drivers to get a charge point installed at their home and switch energy tariff as well. And from the outset, I think a lot of people underestimate the impact of charging an electric car at home and at the right times. So there's also a fiscal benefit for driving an electric car. So obviously you're charging with electricity instead of petrol, and up until recently, drivers could save hundreds of pounds by just making that switch. But now obviously energy prices are through the roof and petrol prices seem to be becoming steady. But charging at home allows the driver to save a lot of money because they are using super cheap off-peak rates of energy, which up until recently were 7.5p per kilowatt. And you're thinking now where we're faced with a standard variable tariff at 40p per kilowatt nearly was a massive saving. And also when you charge really affects the grid. So if you charge during peak hours of the day, so as soon as you come home from work, then you're most likely going to be using non-renewable sources of energy to charge your green electric car. So emissions which don't come out of your exhaust still may come out of, you know, a gas turbine during peak hours. And so the national grid relies heavily still on non-renewable sources of energy during peak hours to reach demand. And overnight, the distribution sways more in favor of renewable energy. And this allows for drivers to be the greenest that they possibly can at current state. There's also loads of different other factors as well. But enough on the benefits of charging your car at home. At Right Charge, we're really focused on creating a super seamless journey. And as you've probably noticed, making your life greener is quite a feat and requires so much effort. And I think, Beatrix, you know, I think the amount of effort you put in is brilliant, and you know, definitely leading the way for others. And we're trying to make that easier, specifically for charging your car at home. So that's why we've created a platform which aims to do that. So I've just put together a few slides which goes into some of the problems that we're facing and how we aim to solve it. And hopefully this is applicable and helpful to you guys. So in short, home charging experience is completely broken, and 59% of customers find an install process overwhelming. And as a market, we really try to solve that. And what we're trying to do is at point of sale, so when you buy your car, we integrate with who you buy your car with to really just create that natural next step of getting a home charge point, switching energy tariff to tap into those cheaper off-peak rates overnight. And we're coming at it from a tech-first business, so using inspiration from platforms like Airbnb to try and create a super customer-centric platform. So I appreciate I've run out of time, but you know, we also try and make other aspects of the installation super easy as well. So apologies, I've run over, so I'll stop there. But hopefully that was a whistle-stop tour on what we do.
Thank you very much, Tom, and thanks for keeping, you know, track of the time, and for sharing your screen too, that I can see again. I wish I was on that, but thanks for that. Yeah, no, it's great to also, you know, think is a house, but it's just what's happening just outside the house too. So am I right also to think that you are still looking for some funding at the moment? And put you on the spot, but there might be some people here, investors and so on, so feel free just to confirm or not.
Unfortunately, yes, I'm not close to the funding as much as our founder Charlie Cook, but yes, we are raising another seed round this year, and I think it's closing very soon. So if anyone is interested in hearing more, then feel free to reach out to me, and I'll put you in touch.
Perfect, thanks. So we've seen, you know, example of a house. We've heard about retrofitting and electric vehicles, but we in Cambridge. So Cambridge also have the university, have very old and listed buildings. So I would like to invite Oliver Smith to talk about, you know, how to retrofit listed buildings. Oliver, over to you.
Hi there, everyone. Yeah, this is really difficult in 5 minutes because we've been for about 20 years, and there's a lot to discuss. But
you are on mute, Oliver.
You've just muted yourself.
The short answer is to know where you're starting from, to cut down your demand, your heat loss and system inefficiencies before jumping to install a renewable heat source. If you insulate, you've got to ventilate, and I'd recommend you do this a step at a time to reduce your costs and to understand the effects, unintended consequences, benefits of each step. This is based on a series of retrofit projects we've done. I went back to Trinity this morning to look at it, and it's looking fantastic, and the client is really happy. It's a very healthy building. In terms of knowing where you're starting from, obviously you need your fuel bills, but you also, I think on listed buildings, there's a range of possible in situ kind of fabric performance measurements that give you a real insight into the design and what you need to get consent for. I mean, on Trinity, this is New Court Trinity, we did absolutely everything, and some of it I think probably had pretty limited application, but I think in situ U-value measurement is an amazingly informative tool, and obviously thermal imaging combined with air pressure testing will tell you a lot about where you're losing heat. This kind of information is now required by Cambridge City Council's adopted planning policies. They basically took the methodology we worked through with them on the Trinity project and turned it into their policies. I think knowing where you're starting from can save you a lot of money, because the fabric of listed buildings often performs so much better than the prediction of software models, and can save you from damaging your building fabric by over-insulating it and then creating conditions for mold growth and dry rot. I seem to have missed a slide. Yeah, that's Cambridge's adopted planning policy, and they look for measured data of existing environmental performance of the building's fabric as a precondition to discussing what you might do with it then next. In situ valuation of walls, a SAT model assumed value for a solid wall 2.2, standard U value calculation from Build Desk 0.94. If you actually measure it, you end up with something like, on Trinity, we ended up with values of an average value of 0.69 watts per meter squared Kelvin. That's 36% difference between the measured and calculated values, and 320% difference between the measured and assumed U values. So it's really worth doing. It's probably better to aim for the best achievable for your specific building rather than aiming for a badge. There's a lot of talk about NFIT at the moment. The Trinity figures, we are doing better than NFIT in terms of the actual kilowatt hours per meter squared heat energy used in the building, but we don't meet all of the criteria, and that's because of the sensitivities of some of the forms of construction and fabric involved, and certainly getting air permeability down to 1 meter cube per meter squared in a listed building is really tough. I mean, we aimed for 3, but we started at 11. So there are swings and roundabouts. I wouldn't go for a badge unless I really needed to, because you can saddle your project with targets and risks that you just can't safely meet. Why is this going? Some immediate suggestions for potential suppliers from my address book. Obviously, others are available. The amazing new vacuum glazing product on the market came to talk to Cleantech earlier in the year. Fineo glazing from Belgium. Ventrola do a really good draft sealing system for sash windows. And then there are any number of breathable, make your historic buildings have breathable walls, make them vapor permeable, don't use plasterboard, don't use OSB, keep the moisture and air moving through your construction. Installation of raised suspended floors, very difficult, but we just used Qbot on a project in Oxford, and heat recovery ventilation as Beatrix used in her house. We used it at Trinity. Historic buildings quite often have chimney flues, perfect place to stick your supply and extract ducts. And that, I think I've probably overrun, is that.
Thanks, Oliver. You must have seen quite a lot of challenges over the years, and I'm quite grateful that you can find some solution for, saving these old buildings and making them more efficient. So thanks for all your work. So at Cambridge, we have old buildings, but we also have very new buildings. The city is growing, and we can see all over that there are new developments coming out. One of the latest and a big major one is a development in the north of the city. And I would like to invite James Coates from Town UNI to talk about new development in Cambridge and how you make them sustainable. James, over to you.
Amazing, thank you, Sylvia. So yeah, I'm James Cox. I'm a development manager at Town, and we're working on the core site in northeast Cambridge, which I'm going to talk to you about today. Let me just flick through. So we're working with an organisation called UNI, and together we are the kind of master developers of the core site, which is a really long-term project. It's the kind of last large-scale brownfield site in the city, and one day it will be home to over 10,000 people, which is slightly mind-blowing, but also very exciting. So you and I are kind of experts in mixed-use regeneration, and I work for a company called Town, who are a smaller kind of SME developer who focuses on creating good places for better lives. We've done one scheme to date, which is Marmalade Lane at Orchard Park in Cambridge, which some of you might have heard of or even visited. So this is our site outlined in red. As I said, 48 hectares located on the northern edge of the city, close to Cambridge North Station, which is that kind of black dot there. And the site itself is surrounded by a number of largely commercial uses, innovative places to be, such as St John's. We've got Cambridge Science Park, Cambridge Business Park, all immediately surrounding the site, as well as kind of residential areas of East Chesterton, King's Hedges and Milton Country Park. And what's exciting about this site is that the scale of it is so vast that it provides us the opportunity, as well as the necessity, to try and do things differently, and to try and do things within the context of the climate emergency, which we're all unfortunately working in at the minute. What we've tried to do at the start of the project is to set out a clear vision, including some kind of guiding promises and values which guide us along every single step, not only in the design work we're doing with the professional team, but in how we procure, how we engage, and ultimately how we deliver the project as well. Particularly relevant for the session today is our promise to the planet, which is that the core site will be an exemplar development fit for the challenges of the 21st century, of which unfortunately there are a lot, and an enabling sustainable lifestyles by default, so meaning that people's automatic choice will be something sustainable, and accelerating the transition to a net zero carbon world. Underneath those promises, we have a collection of values around being kind of rooted in Cambridge. So the site will be a really key part of the city moving forward, that it will be shaped by many, and I'll kind of touch on that later. And again, that it will be a place that kind of lives within our kind of own means. So that means that the core site will be a place that's going to be innovatively designed and constructed. It will make the most efficient use of valuable natural resources, such as land, by building high density, water through water sensitive design, and designing kind of low energy buildings. And we think that doing that amongst a plethora of other tactics will help us to fight those challenges that we're facing today, whilst making it easier for people to live more sustainably day to day. So sustainability and quality of life is a really, really big focus on the project. We've just kind of started out really, but we've been working very closely with a sustainability consultancy called Useful Projects. And we wanted to set a framework for decision making through this project. And what we've done is we've come up with our sustainability and quality of life framework, which you can kind of see on the right hand side here, been inspired by Kate Raworth's donut economics, which nicely aligns with our kind of project values in terms of making sure that we meet the needs of everyone that's going to live here, whilst also living within the means of the living planet as well. In particular, there's a number of kind of planet focused themes around climate, so considering whole life carbon and life cycle carbon, nature, thinking about kind of biodiversity and water sensitive design, pollution, thinking about light and noise, as well as waste, and then resources in terms of thinking about kind of the use side of it, so water, energy use, thinking about circularity, as well as the place we'll be creating. So we've set this up at the start, and it's going to be very much a kind of iterative process between the design team and our sustainability consultants in setting targets and testing those targets through the master plan process, and iterating them along the way, which is something we're pretty excited about. The other reason, the other thing that I wanted to touch on today was that we've got one of our first engagement events coming up on the core site, and this is the People, City, Planet Festival, which will be on the 29th and 30th of October. Going to be lots of different talks and workshops and panels, specifically around sustainability. So Useful Projects will be talking in a lot more detail about the donut that I've just shared, and we'll be hosting workshops on how we design a place, which includes kind of water sensitive design, as well as mobility and placemaking. So I'll put a link in the chat, but would be please do come along on the 29th and 30th to our festival at Shirley Primary School in Chesterton.
Thanks, James. I'm sure we will hear from your development quite a lot in the next few years, but I invite everybody to come to that open day and see what you're doing and enjoy that. It's a new constructions, but it's also building a community. So that's quite important to, is fighting together for the climate and looking for solutions with new buildings, old buildings. Any solution is good. So thanks for that. So now, first of all, I would like to thank all the speakers. And now I'm going to invite also the questions. So stay with us, it's not finished. I'm sure you have lots of questions. And I would like to invite also Oriane, my colleague, to also share with me and ask the questions to the speakers. Big thanks to Oriane too. She was behind the scene making this event happening. So Oriane, do you have any questions?
Hello, hi. Thanks everyone for joining us. So there's a few questions for Tom actually. So yeah, Tom, the first question was, can Right Charge do vehicle to grid charging?
Vehicle to grid, yeah, it's so exciting. For those of you who don't know what it is, it's basically at the moment energy flows from your home to your car. Vehicle to grid is the other way around, which if you treat a car like a battery means that we basically have national grid with a massive storage facility, which means that we can tap into renewable sources of energy during peak times, which then, as I was talking about, basically reduces our reliance on non-renewable energy production. So at the moment, vehicle to grid is in its trial phase. So I think Octopus Energy are trialing that with I think maybe OVO, and it's been really successful. But it's just not ready to go to a nationwide scale and be a sort of consumer-friendly product. But we hope in the next couple of years that V2G will be something that we can offer along with the rest of the market.
Okay, thanks. And just another one for you. Do the Right Charge provide the user with the opportunity to charge at the lowest emission periods within the 24-hour cycle? You might want to explain as well that.
Yeah, this is brilliant. Bit of a learning experience for everyone. So what we class as charging during those lower peaks is called smart charging. And the newer chargers on the market all have the ability to smart charge. And all that is to schedule your charge at certain periods of time. So you plug it in when you get home from work at 6 p.m. It doesn't start charging until 2 a.m. Or even before that, sort of around midnight, where that sort of low peak time period starts. So most chargers do. So the answer to that question is yes. I think there's the OMI charger. So there's one specific brand of charger which allows you to tap into or connect with your energy tariff, which then can sync up to like the greenest periods within that sort of low with off-peak time. So like a 2-hour time period and a 6-hour off-peak period. So the answer is yes, quite simply, yeah.
Super, thanks. And then, yes, Sal, we have a question for you. So that's from Dr. Sorry if I mispronounce, Zulsa Mayer from EcoSync. So she missed the beginning of your question or of your presentation. So the question is this a retrofitted solution, or do you need to bring in your radiators and replace existing ones?
Can be both. Basically, the radiators, they come in a box. So in real terms, you can install them in a new building. I would say 70% of what we do is retrofit. We remove storage heaters, panel leaders, oil, LPG system. We remove 25 kilowatt of storage heaters and we put in 6-7 kilowatt of our system. So yeah, retrofit or new build. Because of the SAP of the new building, you don't need 25 kilowatt in a house now. Sometimes we do some flats in London and we need 1.5, 1.8 kilowatt for the whole house because they're well insulated and the SAP the delta is really good. So you can use both.
Okay.
I don't know if that answers the question.
Yeah, I think so, unless someone wants to jump in, add anything else.
Any questions? Please. I've used only 5 minutes on my 10 minutes.
You did really good. All right, so I have another question for Tom. That's from Peter Bates. So the question was, how does RightCharge's proposition take into account using an EV battery as a home battery storage device?
That's a really good question. And I think may tie into a feature of certain charge points, which is solar integration. So in essence, solar integration with a home charge point allows for your car to be charged directly from the energy that you generate using your solar panels. So without going into too much detail about solar configurations in the home, so normally you have solar panels and then you may have a battery to store that energy, which allows you to, similar to the V2G proposition that I was explaining, allows you to tap into the energy that you produce with your solar panels during the day and charge your car overnight. So some chargers like the Zappi, for instance, is a really good charger for doing this, and allows you to use your energy from your solar panels to charge your car via a battery, so like a Tesla Powerwall, for instance, which means, I know people who have this certain charger and they never use any electricity off the grid. So hopefully that answers your question there. Thanks for all the questions, by the way.
Yeah, I think you had quite a few. So yeah, one last one, and then we're going to the breakout room. I haven't had the time to go through all of them, but yeah, one from Hannah Baker for James. So James, you mentioned circularity in terms of energy transition. To what extent is embodied carbon being taken into account, and do Cambridge Local Authority have any requirements on this?
That's a great question. Yeah, embodied carbon is definitely being taken into account and is one of the kind of pieces of the donut under whole life carbon. We've done a kind of mapping exercise to set our own targets at the minute, particularly thinking about kind of national industry standards around like the LETI guide and REBA 2030 to set a benchmark for embodied carbon. So that is, yes, definitely something that we're taking into account. The council themselves, we're within the North East Cambridge Area Action Plan area, and so they're bringing forward a new kind of planning policy document for the area, and there are quite stringent policies around sustainability. I'm not sure off the top of my head whether they go as far as embodied carbon, but I wouldn't be surprised, as generally we've seen a kind of nationwide efforts to really tighten up on detailed policy elements like that. But Oliver might have a better idea.
Yeah. Oliver, do you want to add anything to that?
You're on mute. No, Oliver, you were on mute, but if you want to add something.
Oh, no, I don't want to add anything at the moment.
Okay. Good.
Okay.
Oriane, do you have any? Yeah.
I was just thinking, just before we go into the breakout rooms, just giving the mic to Beatrice one last time, just in case you wanted to add anything about, the core challenges and opportunity as a homeowner. And then after that, we can go into the breakout rooms.
No, I think people benefit most from the breakout rooms themselves. If there's any other questions, I'd be delighted to answer privately. Yeah.
All right.
Good.
Okay.
So, yeah. So, Oriane, you're going to open the breakout room for 10-15 minutes. I'm conscious that it's probably a lunch break for everyone. So I would like to thank again all the speakers today. Thank you for everything. And also another aspect that you may think about is your workspace. For example, today our office is at the Alia Future Business Center. I like it very much because it's very sustainable. So also think of that aspect. It's a home, it's the retrofitting the universities, it's everywhere we're going. We need to think sustainable. So thanks everybody, and see you in the breakout rooms.
Thanks everyone. If you, I'll stop recording now.